Hello, welcome, and this is an episode about a new device that I got. I traded it in because they're usually pretty expensive, and the person who got it doesn't have any equipment to pair it with. But I do. I have the Commodore PET that we visited in a very old video already. And I'm using the SD to PET SD card adapter for loading stuff, but I always thought something more appropriate for this machine would be a Commodore disk drive from that era, namely this model 8050. There are different variants with 1 or 2 floppy disk drives, single-sided, dual-sided, etc. But this one was available, so I got it, and it wasn't clear if it works. It does turn on, and that's already a good sign. Spindles are working, etc., drives are working more or less, but the disks that this machine uses are actually quad density disks with a completely different format from the 1541. So I can't write disks in my 1541 from the C64, and I need to format disks in here. I don't have any quad density disks, but I read that you can use double density disks to a certain extent, maybe with lesser reliability. So we're going to try that, or rather I already tried that, and I'm getting formatting errors all the time. So I think we need to open up this machine and have a look inside, what it looks like, what the problems might be, etc. It seems to be that the machine is relatively in working order because electrically and the whole CPU and stuff inside seems to be working, otherwise we wouldn't even be able to communicate with it. So that's a good sign. But as it is already 40 years old, there might be some issues, and we'll have to figure out what that is actually. So yeah, let's have a look inside.
Having a look inside reveals the two disk drives that are actually in this machine. These are two 5¼ inch Micropolis full height single-sided double density, no, not double density, but quad density disk drives, which are a bit of a rare beast. Most of the drives of this era were double density for roughly, I think, 250 kilobytes of unformatted capacity, and these have something like 500 kilobytes of unformatted capacity per disk side. They were also available in double-sided with 2 read and write heads, but these only have 1. The logic board here, the controller board for the disk drives, can actually control both disk drives at once. You see here the read and write head connections for a single read and write head each. One goes to the left drive, one to the right drive, but there are connections for another read and write head, so you could swap out the mechanics and probably would need to change something on the main board or maybe in the ROM to support that. There's also the electrical connections that go to the different stepper motors and the main drive motor. This is the stepper motor for the head. This is the drive motor. You can't see the one under here. Yeah, but that's more or less it. At the back you can see the transformer for the mains transformer and the mains filtering caps. I think they are optional. They are more or less to avoid producing noise that will get back into the electrical system. Yeah, but I will leave them in as they seem to be good so far. Yeah, that's that. And let's have a look at the main board. The main board is actually rather complex, typically of the Commodore disk drives of that era, even more complex than the one in the 1541. Most notably, there are two 6502 CPUs, one over here and one down here. I think this whole section down here controls the IEEE 488 port, which is the parallel interface. which was a standard interface used by a lot of scientific or measurement equipment designed originally by Hewlett-Packard, but also used by a lot of other companies. So you could have a bus with lots of different devices for measuring or data storage, etc. Which is also showing that this was a professional device and not like a home computer hobbyist thing per se. Definitely intended for the business market first and for hobbyists only second. So we have the 6502 down here. There are also two Riot chips, the 6532, most prominently used in the Atari 2600. Also to do with I/O timers, and also each sporting 128 bytes of RAM, which might be used by the IEEE interface, I'm not sure, but there's also two ROMs here for that purpose. Up here we also have one 6522 VIA chip, which is also for peripheral interfacing. This one here could be a ROM or maybe some PLA style thing, not quite sure. This up here is definitely a ROM. Yeah, then this is probably more like a PLA or something. There's also a bunch of SRAM chips up here, which is the RAM, I guess, for the drive section. This whole thing would run the disk operating system. Yeah, so it's a rather complex device, multi-CPU, and in theory it even has more computing power than the PET itself, because yeah, you have two CPUs, but they are pretty much busy just talking to the disk drives and to the computer. So I don't think it was ever utilized in any other manner. Quite different from the C64 with the 1541, where people would install their own IRQ loaders into the RAM and the CPU of the 1541 to speed it up. But yeah, this is basically just very stock, and I don't think anyone used it for anything particularly interesting. But yeah, that's what it looks like. Very clean board, very well laid out, pretty huge as well, and definitely also a cost factor, because this was of course expensive to make with this amount of chips and this large size PCB. Next up, we'll take out the drives here and clean them thoroughly inside and out. I also got a cleaning disc, which will help me clean the disc heads, because I already saw that it's very hard to reach them from the outside, and you can't really disassemble the whole drive due to, I think, rivets and stuff like that, so it's not all screwed together. So yeah, let's do that. Have a look at what the disk drives can do. I already tried formatting a couple of disks, but I'm getting format speed errors, so I assume that there's something wrong with the drive speed, and there are multiple reasons. It might be the belts, it might be the motors or lubrication, or maybe even the power supply. Lots of stuff that is possibly wrong here.
First of all, let's take apart the drive 0 as far as we can and then clean everything. So we can remove the top PCB, which is basically all the logic to drive the whole mechanism basically and to read out the read-write heads. And it does this, as I said, for both drive 0 and drive 1. And it can control up to 2 sides, although we have only a single-sided drive here, both in drive 0 and drive 1. So taking off the PCB reveals what's underneath, and there's not that much to see except for a bunch of ICs and resistors here, and it's in pretty okay shape, I would say. A little bit dusty, but we can clean that. Below you can see the drive mechanism, at least parts of it, but everything is pretty much closed up
and the whole frame is riveted, so there's no chance to take it apart further without drilling off the rivets, which I'm not gonna do here because it doesn't seem really necessary right now. Maybe if there was a rebuild. The drive belt is a bit worn out because this thing hasn't been used in many years, I guess, but there's also not much we can do about that, at least nothing I want to do. But it's a very strong belt, doesn't seem very rubbery, so I think it should be fine. Nevertheless, I'm going to clean everything here, mainly all the moving parts. The drive belt touched like the spindle and this flywheel, so we're gonna clean this with isopropyl alcohol, and all the exposed parts will be cleaned too. I will try and remove as much of the old grease that is on the rails and stuff, at least where I can reach it, because it's a bit hidden, and then put new lithium grease on there as well. And the front bezel also gets a nice clean because there was a lot of dust accumulated on there, but all in all this seems pretty nice. There's nothing broken off because the plastic is of course very old and starts to become a bit brittle, so yeah, I'm super careful here not to break anything, but in the end it looks actually pretty nice and shiny, at least for 40-year-old plastics and hardware. Last but not least, the PCB gets a nice thorough scrubbing with pure IPA. You could also do this with water and mild soap or something. I usually just use IPA, but sometimes water might be more appropriate as it can remove more dirt. Next up is the transformer. It's this big block over here, and in the olden days we would use 220 volts here in mainland Europe, and in the UK you would have something like 240 volts, and during the time when Britain was not leaving the EU, we were all trying to agree on 230 volts. Nowadays we have between 230 and 240 volts here, so the transformer will output a little bit higher than usual stuff, because outputs here I think 8 volts and something like 16 volts that get tapped off here and then will be regulated down with these linear regulators here, which get pretty hot if they are fed more voltage than usual. So there is also the possibility when going from pin 2 and 4 to 2 and 6 to switch to 240 volts, and these things will run much cooler. If we have a look down here, I have to carefully twist this a little bit. There are the pins here, and these can be used then. We need to put this cable from here over to here. So I cut away the heat shrink that was over there. The machine is obviously not plugged in. Never do this when plugged in or anything. It's should also be discharged, so it wasn't used for a day or so. Although I don't think that these capacitors hold much charge now. Not even sure if they are at mains voltage, probably not, but I'm not going to risk anything. Carefully desolder the wire and make sure to do a proper job here, because this is actually the mains voltage. So don't do this at home if you're not familiar with this stuff. Also make sure to put a fresh new heat shrink tubing over there, because afterwards you won't be able to. I think this should do it. Now we have to screw the transformer back in place, and hopefully this thing will now output a little bit less voltage and the linear regulators will run less hot. So there it is, and I think we can put it back together because there are no drives in here. I quickly tested it and at least it powers on. The power LED blinks as expected. So all the drives are back in, they are not screwed down. I have attached the head cables, which are in the front here. As I said, this board supports up to 2 dual-sided floppy disks. We have 2 single-sided floppy disks, so we have only 2 of the 4 connectors here. Note down the orientation of the motor and electronics cables here, and also the power supply, the LED, etc. I put a little marker here with D1 so I know which LED is which. You should definitely take pictures of that, and I will put a zip tie around here to make it less likely to touch anything while the drive is moving, but not right now. And I'm also not screwing them in quite yet, because first of all we will try to format a couple of floppy disks in each drive and also to read and write. And once we know that that's good, we are basically good to go. We can close this thing up and hopefully it will live for another 40 years or so with a little bit of maintenance here and there. As it turns out, the drive doesn't format anymore and it gives me format speed errors again, which I had in the first place, which means that the drive speed somehow changed. I think that might have happened when I cleaned the PCB, because the transformer changing shouldn't do a thing. I measured all the voltages here, they are fine, they are exactly +5 and +12 volts. So what I did now was get out the service manual, looked at the schematics for the analog board, which is this thing here, and this thing actually also controls the motor. For example, when you close the latch, it will turn for a while. And right now it actually looking quite good. As you can see here, the drive speed looks pretty okay, but I always have to close the latch and then it will run for a second. So what I did, look up in the schematics the IC that controls that, and when I push this switch here, it will turn continuously. And the middle ring here should look stationary, which it mostly does. It is a little bit drifting. We are looking at 60 Hertz here, 60 frames per second, and it's looking okay-ish. So we can do one more try at formatting. Maybe it will work this time. I'm gonna switch this off for now. And we'll try and calibrate both drives. I bet in the current situation that it will work. The question is, what happens if I turn this sideways again? Maybe it's running now fine because it's in this upright position. Yeah, but let's see. Now it's actually still saying format speed error, and if I turn it now in this manner, well, it is looking okay-ish, but there's a little bit of flutter, I would say, here, and also, as you can see, it is definitely running fast or slow. I'm not quite sure which. There are 2 little pots here. Let me turn this off for a second. That control the drive speed basically. And they have some orange Loctite on them, so we will have to scrape that away and test again. So interesting enough, the pot over here was almost to its minimum position, I think. At least it was turned all the way to the left, and I can still turn it to the right. Turning it to the right will increase the speed of the motor. I turned it now all the way to the left, and now it looks to be very stationary, as you can see here. So that is actually a very, very nice 300 RPM on 60 Hertz. And I actually formatted the disk successfully. I can try and load the directory. Oh, that was the wrong drive. I loaded from drive 0, which will do a quick head banging, which doesn't work, and it complains that there is no file, which is correct. So let's do the same on drive 1. Now it's running. Very stationary, very nice. And it's saying ready, so I can list, and yeah, you can't see it from here, but the pad over here is displaying the contents. So that's fine. I'm gonna turn this on its side now and see if it still works. And if that does the trick, I think we're gonna adjust the other port for the drive 0 actually. And as I feared, once this thing is in the horizontal position, it doesn't run as well. I'm wondering if this is due to lubrication of the drive mechanism or something, that it doesn't spin correctly. I definitely have to take this out again and see what the stroboscopic wheel on the bottom says when running this way. I can't access it because there's no hole in the button where I can check. Different from the 1541s, where you can roughly see through some ventilation openings what the wheel actually looks like while the drive is working. Okay, so that's a bit of a problem. Might be fixable with some lubrication, but it might also be that the ball bearings in the whole mechanism are not very good anymore. It might require full disassembly, which I'm really not keen on doing because the drives are riveted and I'm not very keen on doing something like that. So I propped the drive up and did another formatting run, and as you can see here, this time it worked. It says ready. No error there. So I would say that the mechanism here is a bit marginal. I will put a little bit of lubrication up here, which shouldn't do too much, I think, because this is just holding the spindle in place. But who knows, everything that helps this thing. But as this one actually turns to drive a little bit too fast anyway, I'm wondering if I need to tweak something on the analog board here around the op amp and this pot that are regulating the drive speed, because I'm already at the minimum. So I have to ask some people who know a bit more about this stuff than I, how to get this whole drive to spin slower, and so I can have more leeway to regulate it to a faster speed, because at the moment it is already running almost too fast. Perhaps that is more of an issue. I did notice while it sits in this position that it sometimes takes a second or two to get properly up to speed, which is more the issue of lubrication or the whole mechanism thingy. Once it is up to speed, it runs very, very neatly. And a quick pause here to insert some knowledge that I gained later. People on the forum gave me the hint that maybe not only lubrication plays a part here, but also the aging capacitors and linear regulators that power the drive. It might be that all these things play together in not being able to supply enough current to get the old mechanism up to speed quickly enough. So what I went and did was what you will see in a minute, is namely that I bought replacements for the linear regulators, modern switch mode regulators, very small, very power efficient, less heat, and they should be able to power this old drive much more reliably. So in a minute we will replace those linear regulators and hopefully get some improvement out of this old mechanism. For formatting, this is very critical. If this thing would wait for a second or two before starting the format so that the drive can settle down, it would probably not even be an issue. But as it is an issue because it tries to format, it's running too fast, and then the format aborts basically. Okay, so what I will do now is I will desolder this contraption and put this thing on its side and check if I can also tweak it. I might just resolder this to the pin for drive 0, so I can also turn it on and off at will. But basically I'm going to do the same that I did for this drive. So next step is the modding of the power supply for the main board. Mainly the 3 voltage regulators, and as you can see I already removed one of them, which goes as follows, because everything is riveted down. These are rivets, you probably know these things. They can't easily be removed. You have to drill them out basically very slowly. Produces a ton of dirt and shavings, so I will use this battery powered drill on slow speed, and I will use this metal, I think it's a 4mm drill, to very carefully drill away at the top until the top starts spinning, and then you can remove it, and when you've done both you can desolder the pins and lift out the regulator very easily, as you can see here. I will do this now, and then we can put in the replacement regulators and see if our troubles get better. For sure it will run much cooler, basically cool to the touch, because these here pump out a couple of watts of dissipative heat, and maybe they will also, the new power supply will also supply better current, faster current to the 12 volt rail, which is these two, for the motors of the drives. If that is not the case, we need to open up the motors and clean them. Yeah, we have to check that because I never did that before, so that might be fun. But let's start drilling away. So one of them is out. It's one of the 12 volt regulators, and it took part of the top of the via with it, because it's really stuck to the leg. I think this is not a big problem. Otherwise I would have to run a rather thick jumper wire, because there is still the bottom part of the via left, but we will have to work very carefully. After all, this particular board is 40 years old, and on this one I have 2 problems. The pin that goes into the rivet is poking out the other side, so I cannot very well drill in there. Probably have to take the Dremel out to cut a little bit into there. And this top part is spinning right now, and I'm worried that I damaged the wire here as well. So yeah, probably also have to Dremel a bit. But 2 out of 3 is already good. Yeah, let's see how we can go on. So all the voltage regulators are out. The last one was this 323, which is, I think, very similar to the 7805. It's a 5 volt regulator, and I think it was on here. The 2 others being the 12 volt regulators. I will check, of course, my photographs to make sure that we don't power the 5 volt rail with 12 volts. That would be very damaging. But now let's clean up the residue here on both the regulator and the heatsink. I think I will just leave the heatsink in here to have it in place, and put in the replacement regulators, which incidentally look like this. They're easy SPC ones. It's the PSU5 no noise, which is the replacement for the 323 or the 7805 respectively, and the PSU6, which is the 12 volt regulator. And both dissipate basically no heat. They are modern switch mode or buck regulators, I think they're called. They have a very high switching frequency, so I think they are basically noise-free for our applications here, and they should be able to deliver quite a bit of current in short amount of time. So I hope that the 12-volt regulator will help us drive the drive mechanisms, the motors, more efficiently and more effectively. So yeah, let's clean up and solder in all the parts. Good thing I double checked the voltage regulators, and some of you probably screamed at your screens basically. So let me see, this down here was the 3 to 3, so the 5-volt regulator, and these are the two 12-volt regulators. That would have been very annoying indeed if I had swapped that. So let's pick the PSU 5 first, and I'm gonna put it in something like this. If I can manage to put it in. Yes. And I will screw it down. I do have not rivets this time, but some screws, which are a bit too long. But by the way of screwing it in from the bottom, we should be fine. And it doesn't need to be super tight, it just needs to make good contact to the ground plane, basically. It's a bit of structural support, but doesn't need to hold a lot of weight or mechanical stress or whatever. So that's what we're gonna do. So that's the first one. Now we need 2 more of these. And I have quite a bunch here. Also for modding the 1541s. Yeah, looking good I think. Only thing missing is soldering in all the pins. But that's only 6. With quite a bit of thermal mass, so yeah, but it's usually pretty easy to solder these. I will double check that I put in the correct voltage regulators. Now it's still time to replace them if needed. I noticed there's a little botch wire which seems to be from factory. Well, that's okay. Things like that were quite common and still are in some applications. Yeah, those screws are a little bit sticking out, but doesn't hurt because there's the huge heatsink anyway. So we keep the look basically of the old regulators. And by the way, you can't see them anyway, so I think that is pretty neat. Yeah, I think we're almost ready to put everything back together and retest the drives and see if they will work better with the new voltage regulators. Quite an interesting design anyway, but enough talk, enough speculation. Let's get this running.
Yeah, so that is the repair of the CBM Model 8050 floppy drive. And as you can see, it was successful, I would say. I didn't show the whole debugging as I did before, because basically it's running fine now. So the linear regulators probably were at fault, maybe the capacitors that powered them as well. But the switch mode regulators are definitely providing more power or more current now to the drive so that they can start up more quickly. I could format a couple of disks just fine. I do get occasional bad disk errors with these Fujifilm MD2D disks, but I don't get these with my no-name branded black floppy disks. So I think the media here is a little bit different, might be due to age or whatever. But as stated before, the 8050 actually isn't a double density disk drive, it's a quad density disk drive. I would technically need quad density disks, and again high density disks, I have a bunch of those as well that were used in the PC for 1.2 megabytes. It won't work because they have a completely different magnetic formulation. That won't work in here. But the quad density would be a little bit higher grade, but with basically the same coating. I have 4 of those new old stock on order. Let's see if they will work, but I didn't want to delay the video anymore, and it works. Basically, depending on which disk type I use, I can run directory, I can save and load, I can format. And that's all I wanted to do basically with this device. I still have the SD to PET, by the future was 8-bit, so I can get software anyway onto this machine, but having a true floppy drive here is actually pretty neat. The problem is getting stuff on there, because I can write a couple of basic programs and save them on the disk, but that's no fun, and I do have 500 kilobytes of storage on each disk basically, which I can hardly fill with basic programs. And this would have been a very mean setup actually back in 1979 or 1983. This machine is from 79, this from 83. Quite a substantial amount of disk space actually. So I can probably daisy chain the SD to PET in here as well, using a different adapter that I don't have, but I'm probably not going to do that. I do have another order from the US waiting for a Zoom floppy, which is a USB interface for modern machines for all the Commodore disk drives, including the IEEE ones like this, but also the regular IAC ones, the 1541, 1571, 1581, etc. And you can use the open CBM tools to read and write to those. And that's what I'm going to do. If I have like 4 disk sites or something, or even more available, I can write a lot of stuff on there. Probably a substantial amount of the PET library can fit on there. Maybe even PET robots or something that we can play that from original floppy drives. That would be very nice. I, for one, definitely do miss floppy drives and the haptics and manual feel, and also a bit that it takes a bit to load and do stuff. And yeah, for hobby I like this very much. For work I don't miss floppy disks at all, I must say. But as a hobby I like that very much, just like vinyl records or something where you basically have more physical interaction with the stuff that you're actually doing. And yeah, I would love for floppy disks to make a comeback in the hobby sector, but I very, very much doubt it, because it's much harder, I guess, to produce floppies and floppy drives compared to, let's say, vinyl records, plus the market is probably also only like 1% of what the music market actually is for that stuff. But enough rambling on. This is the setup. Let's see how far we can take it. But for this video, that's it. Please share, like and subscribe. Sharing on social media is definitely always a good idea. Brings more people to this channel. You can also find me, for example, on Mastodon. All the links to social stuff are in my profile. You can also support me, Patreon, Ko-Fi, etc., etc. Everything is down in the video description. If you can't do that, make sure to leave a comment, and yeah, I'm always very eager to hear your stories and read all the comments, although probably not responding to every single one, but it's very interesting to read your stuff as well. But that's it for today. I'm gonna turn off the PET now and say good night.